let's have another example on the application of the computation, I should say, computation of moment of a couple. A steel plate is acted upon by two couples as shown. Determine the value of alpha if the resultant of the two couples is 10 Newton meter counterclockwise, yung resultant. Okay? So, I will be presenting a different way of solving itong problem na ito. Iba yung na-present dun sa module, no? So, this would be another way of solving it. Okay, shorter yung nasa module. This is a bit longer yung solution, pero I think para ma-apply din natin yung principle of moments, yung Variance theorem. Okay? So, sa solution natin, we're going to resolve now yung inclined force into two components. Okay, Fx and Fy. Okay? So, yung sum or the resultant ng dalawang couple is 10 Newton meters. Pinag-add natin, the result would be 10 Newton meter. Counterclockwise, so negative siya. Okay. So, let's do it. First, we need to solve for the components of each force, Fx and Fy. Yan, in terms of alpha na lang. In terms of alpha. Nag-blurred yata dun sa video. So, Fx is equal to, so yung Fx natin. So, 24 cosine of alpha. And Fy is equal to 24 sine of alpha. So, yan. Yun ang kailangan natin. Anyway, given naman na yung itong 14 Newton force. So yung moment natin is equal to, given pala yung resultant moment natin na 10 Newton meter counterclockwise. So, negative 10 Newton meter. So, lagay din ng negative kasi it's counterclockwise yung direction ng resultant moment. Okay? That's equivalent to yung moment ng 14 Newton force, which is, if you try to imagine, it's counterclockwise, yung moment ng 14 Newton couple. Ayan. So, that is minus 40 newtons times its distance between the two. Obviously, that's 600 millimeters, or that is 0.6 of a meter. Then, yung moment naman ng Fx. So, it is Fx yan. Fy ito. So, Fx natin. This is Fx. Okay. So, Fx, or that is 24, Fx produces a clockwise moment. Okay, yung Fx couple natin produces a clockwise moment. So, that is 24 plus 24 sine alpha times yung distance between yung Fx natin. Distance between yung Fx. Anong distance yan? So, ano yung distance between yung couple natin na Fx? So, 800 dito, ano? 800. Tapos, meron tayong 800 ito from here. So, meron tayong distance dito. Itong distance na to. So, this distance. Anong distance ito? So, distance between the two Fx is 800 minus this distance. What is this distance? We know that this side is 600 millimeters. So, we are solving for this distance given yung, hindi ba given, hinahanap na yung, in terms of angle alpha. So, that is equal to, so, opposite, adjacent. So, gamit tayo ng tangent function. So, tangent alpha is equal to opposite over adjacent. Opposite over adjacent. So, yung opposite side natin is equal to, ano, i-cross multiply na lang natin, no? So, that is 0.6 tangent of alpha. Okay? Diba, tangent alpha is opposite over adjacent. Okay? So, i-cross multiply natin, itaas natin yung 0.6, so that becomes x, or x to, yung distance na to is equal to 0.6 tangent of alpha. Okay? So, ang moment arm din ng fx natin is equal to 800 minus this distance. Or that is 0.8 minus 0.6 tangent of alpha. Okay? So, dapat in terms of alpha lahat ito para ma-solve natin yung angle alpha. Next, yung moment naman ng yung last couple natin is yung Fy. So, Fy is 24 cosine pala to. Ay, hindi ba yung naisulat ko? Fx, 24 cosine. Palitan ko na lang to. Cosine alpha. Medyo inaantok ako. So, take note, nagkamali ko ng pagsulat. So, Fx is 24 cosine alpha. Ito yun. Next is yung moment naman ng Fy produces a clockwise moment. So, clockwise, so plus ulit. Plus Fy is 24 sine of alpha. Ayan. Times yung moment arm ng Fy. So, it's 600 mm or 0.6 of a meter. Okay, so we have one unknown in the equation, and that is the angle alpha. So, you can solve for angle alpha. So, alpha is equal to, that is equal to 43.18 degrees. Okay, so that's it. That's how simple it is. So, yeah. And let's proceed to the next example. Next example. Two parallel forces of opposite sense. We have F1. F1 is already in its Cartesian vector form. And F2. So, yung mga magnitudes ay parehas lang, opposite lang in terms of the direction, ano? At points A and O. No. That should be B, ano? A and B. So, points A and B of the body shown in the figure determine the moment of the couple and the perpendicular distance between the two forces. Okay? So again, this is a moment of a couple in 3 dimensions. So, for 3 dimensions, we usually apply yung principle of cross product. Okay, so again, how do you solve for the moment of a point, moment of a force about a point in 3 dimensions, no? So, moment natin is equal to yung position vector cross yung F natin. Okay, so since we have two forces here, so ang kailangan lang naman natin is yung isa lang, and then yung position vector. Ano yung position vector? That is the position vector from yung point where we are summating moments or taking moments to a point where a point at the line of action of the force. No. So since we have two forces here, ito F1 and F2 yan. So we can take any point along F1 and we can take any point along F2. Okay lang yun, no? So first, anong kailangan natin? Kailangan natin ng R. Yung F walang problema kasi it's already expressed in Cartesian vector form. So what we need to do is the position vector, no? solve natin yung position vector. So, pili lang tayo ng points between the two forces. Dalawa lang naman yung ano. So, ito lang naman yung given, ano? Point A, tsaka point B. Yun lang alam natin na coordinates. So, let's just choose those 2 points, no? Yun na lang yung gawin nating position vector. Ayan. Okay, so it means we're going to identify muna yung coordinates ng point A and then coordinates ng point B. So for point A, ang coordinates natin ay 170. These are in millimeters, and this is 150. Sa point B naman, palikod, so negative 100. 100. Okay, 100. And then 90 taas. Yan. So, okay tayo. So, kunin natin yung position vector BA. Okay? BA. Okay. Yan yung solve natin na position vector. So, yung position vector natin are BA is equal to head minus tail lang tayo. Head minus tail. So we have 100 minus negative 100, that is 200. I. And then we also have 70 minus 100. That is minus 30J. All of these are in millimeters. Then 150 minus 90, that is positive 60. Okay. Or is also equal to, kapag naka-mm kasi ito, okay, yung nasa module yata is naka-meters. So, convert na lang natin sa meters. So, we have 0.2 I minus 0.03 J plus 0.06. Okay. This is in meters. Although you can use naman any of the two, no? Sa cross product. So, yung moment natin now is equal to RBA. Okay. Cross, let's just use yung F1 kasi BA naman yun. So, F1. Although, pwede rin naman yung F2, ano? Pero F1 na lang. You can try F2. So, cross product. So, M is equal to the determinant of determinant. So, we have, so yung coefficients ng ating position vectors, we have 0.2, negative 0.03, then 0.06, and then yung ating F1, 125, 200, 250, and our directions IJ. Okay. Then copy using basket method, copyhin lang natin yung first two columns. 0.2, 125, I, 03, J. Okay? Then perform basket method. Basket. Excuse me. Okay, so i-multiply lang natin yung nasa gasaan ng linya natin. That's equivalent to we have 0.2, 200, K. Alright, and then plus negative 0.03 times 250 I plus 0.06 times 125 J. Then minus, minus yung pataas naman, ito, okay. So we have 0.06 times 200 I, ito, plus 0.2 times 250 times J, okay, and then minus 0.03 times 125 times K. Okay? So, join lang yung mga I, J, K. Combine lang tayo. Lahat ng I, add. Lahat ng J, mag-add. Then lahat ng K, i-add natin. Okay, the resulting value would be minus 19.5 I minus 42.5 J plus 43.75 K. All of this in Newton meter. Okay, so naka-Newton meter yan. Okay. Ayan. So, solve for the magnitude M. So, determine the moment of the couple, sabi niya eh. So, solve natin yung and for us to solve for the distance between the two forces or the couple, we need to solve for the value of M muna, yung resultant natin. So, how do you solve for the resultant moment? That is just equal to ito, yung usual na method natin sa pag-solve ng resultants. So, we have minus 19.5 squared okay. So, yung moment natin is equivalent to wait lang 64.036 Newton meter. So, yan yung moment na, resultant moment natin. Okay? Next is to solve for the resultant of the force. Kasi kailangan natin yon sa pag-solve ng distance. No? Kasi if you try to recall, moment is equal to force times distance. If you want to solve for the distance, then we need the value of M and the value of F here. So, alam na natin yung M. We need to solve for F, yung resultant. Okay. F is equal to, so given naman na yung Cartesian vector form ng F natin. So, we can simply easily solve for the resultant force. So, we have 125 squared of the quantity 125 squared plus 200 squared plus 250 squared. So, the resultant is 343.693 Newton. So, kompleto na. We have the moment, we have the force. Now, we now solve for the distance between the two forces. Okay? So, M is equal to force times distance. M is 64.036 Newton meter is equal to 343.693 newtons times D, which is the unknown. So, canceling Newton, we're left with meters. So, cross multiply. D is equal to, what is D? That is 0.186.317 meters. Or that is equivalent to, kapag, if you want it to convert into millimeters, so move lang tayo ng 3 decimal places, so i-multiply natin ng 1,000. So 186.317 mm. So that's the distance between the two forces, or the distance between the couple. Okay? So yan na yun. So ito yung moment natin. Ayan. Okay? So that's how we solve for the moment of a couple in 3 dimensions naman.